Welcome, everybody. We are so glad to have you with us here today. We are doing our Perseverance today, and we're going to be sharing 4 awesome activities. We're doing our first Mars Zoom webinar experience, so this is a little new to us. Yay! We're also going to be streaming this on the Facebook LPI Science Education group. So your friends and colleagues can see it there. If you want to send them there, you are welcome to do so. We are going to be streaming this from the LPI Facebook group. And we're getting started now. Now, folks, if any of you would like to occasionally chat, our numbers aren't so huge that we can't let you do that. We can still let you do that. So what I'm going to do, we're going to give you the opportunity, if you decide that you want to share your cameras, what I'd like you to do is say so in the chat box, and we will promote you to panelists so that you can share your cameras if you would like to. So please, if you would like to share your cameras, say so in the chat box, and we will let you do that. So we're streaming live on Facebook. It's in the process of getting set up. Okay, Linda, you're willing to share your camera. Awesome. So Linda, we're going to promote you. And okay, so we're going to promote a few of you. That way, when we're doing activities, it's always nice to see you doing the activities and sharing your cameras as well. So Linda, you should be a panelist now. C. Scott, you should be a panelist now. John Martinez, you should be a panelist now. Jeff, you should be a panelist now. Patrick, you should be a panelist now. If anyone else decides that they would also like to share your cameras, please just let us know. And then the other things that we're going to do is, at any point, if you would like to use your microphones, you are welcome to say so. Say something in the chat box, and we'll allow you to turn on your microphones or allow you to talk. So great. Antonetta, we will promote you to panelist. So all of you, if we've promoted you to panelist, we'd love for you to share your cameras so that way people can see what you're doing. We are streaming live on Facebook. Yay! So we're glad to have all of you with us here. What we are doing here, we are talking about Mars Perseverance, and there are several of us working on this together. I am no longer checking out, so if people are trying to join on the Zoom link, I'm sorry, it's too late. You are too late. Let's go ahead and share the PowerPoint and get started. And I'm going to do it from the first slide here. So welcome, everyone. My name is Christine Shupla. I'm from the Lunar and Planetary Institute, which is operated by the University Space Research Association, USRA. And with me is several people. Sherelle, could you care to introduce yourself briefly?
Hello, everyone. Glad that you're here. My name is Sherelle Webb. I'm an education specialist with the Lunar and Planetary Institute. So thank you and welcome.
Now, Amanda, would you mind saying a couple of words? And the next slide will actually go into some of the details as well.
Absolutely. Thanks, Christine, and good afternoon, everybody. My name is Amanda Smith Hackler. I'm the Director of Education at the University Space Research Association. And in my capacity, I oversee a portfolio of STEM educational programs that includes NASA internships, the Air Force Research Laboratory Scholars Program, and then USRA's STEMaction Center. This is a very unique center. It operates primarily near Baltimore, Maryland, more specifically in Columbia, Maryland, and serves the students of Howard County. However, we are expanding. We're trying to reach additional students nationwide now. Obviously, the circumstances are not optimal at the moment, and so our center, which is usually accommodates students, is is shuttered. It's an 18,000 square foot footprint. Historically, we have supported programs through FIRST Robotics. We also do a series of highly engaging robotics workshops. This year, we're also going to support an array of educator professional development activities. Now, before I turn it back to Christine, there are a few events that I wanted to bring to your attention, and Christine and Michelle, I'll ask that you interject as well. But February the 3rd, we are going to be hosting a virtual panel in collaboration with the Jet Propulsion Laboratory. And we're going to have a series of panelists supporting the Perseverance mission provide some insight as to what their career encompasses, their unique career pathway, and address any questions posed by participants online. It's going to be a really terrific event. And just to tell you a little bit more about the panelists, we'll have a JPL systems engineer, two actually, working on Mars 2020. I can think of no one more interesting to speak to. In addition to the Lockheed Martin Director of Deep Space Exploration and a Lunar and Planetary Institute scientist. So I hope that you'll join us for that. Now, I would encourage you all to access the link that's provided on this slide. This link will direct you to USRA STEMaction Center. Michelle has compiled a list of pertinent dates, and you can access additional information about each of these things via the website. In addition, just one thing, another event just quickly, February the 17th between 12 and 1 p.m. Central Standard Time. This is kind of our milestone event. It's going to be really extraordinary. We have recruited 3 astronauts, Mary Cleve, Paul Richards, and Alvin Drew, to participate in a panel to discuss the significance of Perseverance and their role as astronauts. Now, we're going to be using a very unique platform known as OpenSpace in partnership with the American Museum of Natural History to conduct this panel. If you have no experience with OpenSpace, I would strongly encourage you to take a look at their resources online. It's really exceptional, and I think you'd really enjoy it. Maybe Christine or Michelle can weigh in a little bit more, but it's really a very immersive online experience. So again, a really exciting lineup, and I hope that you'll join us. And thank you for joining us today. Christine has put a significant amount of effort into preparing a really nice workshop for you all. Thanks, Christine.
Thank you, Amanda. Michelle, did you want to add anything? And please introduce yourself.
Yes, hello. I'm Michelle Hoffman. I am the Director of Corporate Development at the USRA, and I work quite a bit in the STEM Action Center. So we've got some exciting things that Amanda has shared with you, and we've got a lot more in the months and the summer ahead of us. So be sure to visit the website often. I'd certainly like to give a special thank you to Lockheed Martin for helping us, for sponsoring this event today and helping us ensure that we've got a great series for all of our educators and our families out there to enjoy over the next several weeks. So today will be a great start to kicking that off. So thank you to Lockheed Martin.
Awesome, awesome. All right, well, let's continue. The first activity, let's do an activity. And this is the paper strip solar system activity, and it should be familiar to many of you, but it might not be familiar to everyone. And it's a great one to do virtually. So I have here some directions. And if you brought along paper yourself, please take out your paper now, a piece of paper. If you wouldn't mind taping ends to ends to make a long strip. And Sherelle, do you have some models now that you can show people? And I can't see you, Sherelle, because I can't see anyone. So you'll need to have your microphone on.
She does have it.
Awesome.
Yes, and
Yes.
so here is a paper strip that I've made just right out of printer paper. What I did was I folded it and made just 4 different strips, and then I taped the ends to one another to create this beauty right here.
Or if you would like, you can grab, a long strip of toilet paper will work, or construction paper, or, something. But you want it to be,
Christine, I'm sorry to interrupt. It seems that some people cannot see Sherelle.
Oh, let's see. There might be a way to highlight Sherelle's video. What I'm going to do here for this temporarily, I'm going to stop sharing that. And yeah, and I believe that there's a way to do gallery view for me. And there's probably a way to make it easier for everyone to see. Sherelle, go ahead and start talking again. Let's see if that highlights your video.
Right, awesome. Hello, everyone. Could I be seen and heard? So now I am showing you that I took a piece of printer paper and I made 4 different strips out of it. Just cut here by making 4 different strips. And then I taped the ends together. So now I have this beauty of a pocket solar system strip.
Awesome. And what I've done is I've spotlighted you, so you're going to be the main video that people are going to continue to see. I'm going to go back to sharing the PowerPoint. So what I'd like everyone to do is take their piece of paper and let's write sun at one end of the strip and Pluto at the other end of the strip. And so all of you who are sharing your videos, please, if you have paper, we'd like to have you all do it now. Even if this is an activity you've done before, it's always fun to do it again. And we always learn something a little bit new by people's reactions as they do it. So let's have everybody get started. Write sun down at one end, Pluto at the other end, and please write the names of the planets in their approximate positions in between. And while you're doing that, some of you might have favorite ways that you have helped students learn the names of the planets. Does anyone want to share in the chat box or maybe even turn on their microphone and share? What are some ways that you have helped people remember the names of the planets in order? Anything fun? Is anyone entering anything in the chat? Can any of my my co-hosts and panelists tell me, has anyone entered anything in the chat in terms of ideas?
Hey, Christine, we still have some people in the waiting room.
Oh, we do?
Yeah, we might need to release those
Oh,
individuals.
absolutely. Nobody should be in the waiting room. How do we ensure that everyone is not in the waiting room?
I'm looking for that.
I don't see a waiting room anymore. I think there might be some people who might be struggling with things, but everyone should be able to see and hear what we're doing. Let's see here. I don't see a waiting room, so they may please have them join the Facebook stream instead if they're having trouble joining us. So, let's go ahead and continue, please. So Sherelle, what have you got so far in terms of your paper strip? Go ahead and show us.
All right, so as of right now, ladies and gentlemen, at one end of my strip, I have the word sun at UN, and at the opposite end, I have the word Pluto.
Awesome. Does anyone else have their paper strip ready to show us so far with any planets in between? Linda, awesome. Linda, can you go ahead and tell us, are there certain things that you've used with your students and Antonetta, do any of you have, awesome, you've got your paper strips. Do any of you have things, sentences, statements that you've used with your students to help them remember the names of the planets?
Mnemonic devices.
Yeah, I've been trying to remember it. I know it started off something like Sunday, Veronica, and then I messed up in the middle because I can't remember the words that go with the planets. And then Earth is early, the asteroids are and then just stayed until noon, period.
So it's, how about anybody else? Does anybody else have one that they
missing part of
remember?
it.
They're missing part of it. Anyone else? Okay. Some of the popular ones, of course, are My Very Excellent Mother just served us. It used to be nine pizzas, but then people, Pluto's no longer a planet, so they said just served us nachos. One of our scientists has shared one that is one of my favorites after they demoted Pluto. It's many very egotistical men just screwed up nomenclature. So anyway, so there's lots of different ways that people have tried to remember that. So the first part of this activity was to get the paper strip and to write down the names of the planets in order. The second half is to know what the correct answers are. And so we're going to go through that now. We're going to go through the correct answers. And the way to do it is going to involve come on. So everyone now take your paper strip. We're going to turn it over and use the other side. And again, start off with writing the sun and Pluto in really, really small letters, really small letters. And Sherelle, please do continue to share what you're doing so everybody can see. And everyone who's doing this, please show what we're doing. It makes a lot more sense if we can all see. So you've got a paper strip that says sun and Pluto at the different ends. After you've got that, which planet is going to be in between? We're going to fold it in half and we're going to write the name of a planet halfway between the sun and Pluto. Does anyone have any guesses which planet it is that's halfway between the sun and Pluto? And I can't see the chat right now. So Yolanda or Sherelle, if one of you could let me know what people are saying, that would be great.
They are saying they can't see the person who is sharing her screen. Hold
They
on.
can't see Sherelle?
Oh, are you sharing? That's correct. I see you as well. I see just you.
Just me. Oh, okay. Let's go ahead and let's fix that then.
Some people are answering the Uranus as the answer.
Uranus is indeed the answer. You are exactly right. So let's let me find Sherelle's video. And Sherelle, we're going to spotlight you again. And
All right, that's quite fine. So as of right now, ladies and gentlemen, I took my strip and I folded her in half. And this is where I place Uranus.
halfway in between. Awesome. Thank you. So let's see. And I'm wondering if when I spotlight you, if it doesn't pin you. But let's go ahead and let's keep going. Okay, so now that you're right, it is indeed Uranus. Halfway in between the two is Uranus. And after Uranus, we are going to fold it halfway between Pluto to Uranus. And please write Neptune. So halfway between Pluto and Uranus, you've got Neptune. And then fold the sun to Uranus. And halfway between the sun and Uranus, you have Saturn. So at this point, you have your paper folded into quarters. And a quarter of the way between the sun and Pluto is Saturn. And then halfway between the sun and Pluto is Uranus. And then 3/4 of the way over to Pluto is Neptune. And then you've got Pluto. Wow. So now we're down to that very first quarter of the paper. That first quarter of the paper, I want you to fold the sun to Saturn, and you're going to write Jupiter. So now you're less than a quarter. You're an eighth. Wow. I'm sorry. It's getting pretty small here at this point. So this is why it's good to start with a long strip of paper. Anyone want to guess what's going to come next? If we fold the sun to Jupiter, what's going to be halfway between the sun and Jupiter? Anyone want to guess? What are people saying?
The asteroid belt.
Asteroid belt is right. Absolutely. A lot of the kids would, of course, assume, oh, Mars is going to be next, but nope. So the sun to Jupiter, halfway in between, you've got the asteroid belt. And then if you fold the sun to the asteroid belt, you've got Mars. And now you've probably only got about this much space left. You fold the sun to Mars and you're going to write down Venus, not Earth. And then in the little space between the sun and Venus, you'll write down Mercury. And in the tiny little itsy bitsy space between Venus and Mars, you're going to write down Earth. So was anyone surprised by that?
Yeah, definitely for me, it was the first time with this experience. And I think that for my students, it will be great.
This is usually very surprising to most people when they're trying to get it all done. It can be very surprising. So awesome. Awesome. Everybody still with us? Everybody hanging in there? Show the directions again. Absolutely. Absolutely. Let's go ahead and show you. And this PowerPoint, by the way, is available for you to download now. And we'll repeat the website and I'll email you the website as well, where you can download it. But here are the directions. And there's a website here. One of the NASA JPL websites actually has full details. And if you want to make it more rigorous for students, it's got that as well. Right now, we're doing it in a very simple way that you can do this virtually with students over the internet like we're doing right now, or you can do it with them in person, either way. So is this an activity that some of you would use or some of you have used? Let's go ahead and let's do a couple polls while we're here. So how many of you have conducted an activity with your students about Mars before? Have you conducted activities about the solar system, about Mars, about designing missions? No, you haven't, or I'm not really sure if that counts. I'm going to give you all about 4 seconds to finish answering. 3, 2, come on, you can do it. You can do it. You can answer. 1 second. Yes? And somebody was going to comment. Please feel free.
We can't vote.
We can't check it.
Oh,
Yes.
Because you're panelists. I
Yes.
promoted you. I'm so sorry. If you're panelists, it might not be allowing you to vote. Let me see. I think that there's a way that I can, that it will let me allow panelists to vote for the next few questions. So here's what we've got for that first one. A bunch of you said that, yes, you have done activities about the solar system, and a bunch of you have done ones about Mars as well, or even designing missions, and a couple of you haven't. Let me stop sharing for just a second and let me see. There is a thing where I can allow panelists to vote too, because we want our panelists. There we go. That's what it is. So how many of you have conducted an activity with your students virtually? Have you conducted an activity with your students virtually? Now, even when we do activities in person, they almost never go perfectly, right? It takes a few times, and you know, the first period class might not be great, but by third period, it might go wonderfully. And by the last period of the day, they're tired and they're not paying attention anymore. So, okay, it looks like most of you have voted. I'm going to give everybody 5, 4, 3, 2, 1 to vote. And a lot of you have, but some of you also say it could have gone better, you know? So the activity that we just did with the paper strip, is that something you could do with students virtually? Yeah, I see a few nods.
I've also done this experiment in a larger scale inside of an auditorium.
Oh,
Using children as the position markers.
that's awesome. Yes, yes. Having them arrange themselves physically, the human scale model of the solar system.
Right.
Yeah.
That way the rest of the people in the auditorium get to experience the scale.
And you can also make them make their own scales as well. And let's see, I saw a hand up as well. Laura, I'm going to allow you to talk if you want to go ahead and say something.
Oh, okay. So I make things accessible for people that are differently abled. And I've done this activity based on the one that you're doing, though. And I put rings around, I call it rings and strings. And you put a ring and you have them stand and you make the strings the distance. And then they call out. So sun, Mercury, Pluto, and Pluto's like 75 feet away. And this way, if they have any kind of issues with accessibility, that helps them. So they can hear it, they can visualize it, they have this string if they need to follow it. And it works really, really well with people that need special accommodations.
Thank you so much. And I see Dave had put down some things here in the chat box as well about a scale model with, different balls estimating the size of the moon and Mars and the distance to them and getting a lot of wow reactions. So great points. The surface area of the moon is about the same as the surface area of all of Africa and Australia together. And thank you, Laura. That would be great. And Laura, if you want to post the website in the link, you can. Some of our solar system ambassadors are participating today. Not everybody here is a solar system ambassador, but yeah, awesome. Okay, let's do another poll. We're going to do one more right now. If you could take a trip to Mars, would you go? And I'm going to give everybody 5 more seconds to finish answering. 4, 3, 2, 1. And we're kind of all over the place here. A bunch of you said absolutely you would. A couple of you know definitely not. A few maybe not. I'm in the probably not personally. I'm pretty sure I would get space sick. So anyway. We're going to continue now with another activity. If you were younger, you'd think about, even when I was a teenager, no way I would have considered it personally, but I know so many people who would love to go, so many people. Okay, so we're going to do our next activity. We're going to play a game called Mars Matches. And in this game, we're going to look at images of Earth and Mars and vote as to which one is going to be the right match. There's also some multiple choice questions. So to play this game, all you have to do is you're going to enter your answer A, B, C, true, false in the chat box. And you're going to keep track of your own points. I'm not keeping track of your points for you. You're keeping track of your own points. So that's how we're going to play it. And the Mars Match game, just to let you know, is available online. And the PowerPoint version that we created to go with it is also available online and easy to download. You can modify it. It is a PowerPoint, so you can make changes to it for your audience. And if the questions are too hard for some of the kids, you might want to remove some of those questions. If there are questions that you particularly like because they're or you want to add some more questions, you can do that too. So the idea here is we're just going to be looking at pictures. That's all. And so let's share the Mars Matches game. And we're going to play it from the beginning. So, all right, first picture here. It's a picture on Mars. It's a satellite view. You can see some different things. There's some volcanoes and some clouds. Which of these two pictures of Earth taken from satellite view is the best match for this picture of Mars? So I'd like everyone to enter A or B. And on the count of 5, I want everyone to have entered their choice. 1, 2, 3, 4, 5. And Ms. Sherelle, what have people answered?
It's actually I think the most is A.
Most is A. And you should know that because so many people are not familiar with satellite views, and particularly satellite views of icy areas, a lot of the kids and a lot of adults are going to vote B, but the answer is indeed A. A here is going to be. So if you answered A, you get a point. If you answered B, sorry, good guess. We're going to keep playing. Clouds on Mars, are they mostly made out of water or carbon dioxide, or water and carbon dioxide? We're going to let you vote A, B, or C on the count of 5. 1, 2, 3, 4, and 5. What are people answering, Cheryl? B. The answer is actually A. Ooh, good guess. And don't feel bad if you got this wrong. We're just learning. It's a trivia game, okay? We're just learning. No one is expected to know all the answers here. The clouds on Mars are indeed made out of carbon dioxide and water. So here we have a picture of some sands that were taken by the, not Perseverance, but by the Curiosity rover on Mars. And we've got a couple of pictures here on Earth of some different features. Which one of these do you think we should match, A or B? Let's go ahead and vote on the count of 5. 1, 2, 3, 4, 5. And what have people answered?
B.
These are pictures. B is a picture of some sands in Iceland that has similar chemical composition to some of the rocks on Mars, and formed in a similar manner. And so scientists here on Earth actually travel to Iceland and are testing different types of rovers on Iceland to see how they perform. What's the name of the rover that's going to land in Jezero Crater next month? A, B, or C? Perseverance, Curiosity, or Spirit? Everybody vote on the count of 3. 1, 2, 3.
A.
A. Everybody got it. Perseverance is going to be landing very, very soon. Yay. Okay, here's a picture of Antarctica. Which of these 2 pictures of Mars would be the best match? Do you think it should be A or B? Going to give you until the count of 5 to enter your vote. 1, 2, 3, 4, 5. And the answer is?
A.
A. Actually, it's either. So if you voted A or B, you get a point. If you voted A and B, you get 2 points. These are the south and north ice caps on Mars. The ice cap, what is it made out of? Is it made out of frozen water, frozen carbon dioxide, or water and carbon dioxide? We're going to give you to the count of 5. 1, 2, 3, 4, 5. Sherelle, what
Majority is C.
Majority is right. Yay! The ice cap does have frozen water, but underneath that frozen water, it also has frozen carbon dioxide, dry ice. As time goes by, with the seasonal changes, Mars has seasons just like we do here on Earth. And when the North Polar Cap and the South Polar Cap, they both grow when they're experiencing their winter times. And that growth isn't just frozen water. It's also cold enough there that the atmosphere, the carbon dioxide actually freezes. Okay. Here's a picture, a satellite view of Mars. This is a river delta around Jezero Crater, which is where the Perseverance mission is going to be landing. Which of these 2 images from Earth do you think is the best match for this picture? Do you think it should be A or B? Gonna give you to the count of 5. 1, 2, 3, 4, 5. And what are people saying?
B.
B is indeed right. B is another river delta here on Earth. Great. A might have confused some of you. We'll get to A later. How many points does everyone have so far? Everyone go ahead and enter in the chat box how many points you got. We've got to see who's running ahead right now.
Linda and Jim both have 6.
Awesome. Now, you can play this multiple ways. You can set a number and say, when a student or a team of students gets to a certain number of points, then they've won and the game is over. Or you can do all of the slides. We're going to do them all so you can see them. Or you can set it to a certain time and say, we're going to play for 3 minutes. And at the end of 3 minutes, we'll just see who has the most points, right? So there's lots of different ways that you can do this with your classes, with your students. Let's do a few more though, because I want you to get the chance to see all of them. Here's a picture of a dust storm on Mars at the pole. Which of these two pictures of Earth is the best match? A little confusing here. We're going to give you to the count of 5 to guess A or B. 1, 2, 3, 4, 5.
A.
A is indeed the right answer. That's that Sahara dust storm here on Earth that we had. Can dust storms on Mars cover the whole planet? True or false? We're going to let you vote. True or false, right? T or F. 1, 2, 3, 4, 5.
True.
The answer is indeed true. Dust storms on Mars can cover the whole planet. Here's a picture of a dust storm back in 2018. Some of the earliest missions to Mars, when they got there, they didn't see much because there was a huge dust storm covering the whole planet and they thought it was rather boring. We've learned so much more since then. Mars is anything but boring. Okay, so here is a satellite view up in a desert in China, high altitude desert in China. Which of these pictures do you think of Mars should be the best match for this one? A or B? 1, 2, 3, 4. And the answer is A.
How
Yeah.
can we get this?
This PowerPoint is available online as part of that activity, like I said. And when we'll go back to the other slides and I'll show you the website for it. Here's some ice at a crater on Mars. Dust devil. Here's a picture of a dust devil on Earth. Which of these two images from Mars is the best match? A or B? We're going to count to 5. 1, 2, 3, 4, 5.
B.
B. Actually, this is another one of those tricky ones. You could have answered A or B. If you answered both, you get 2 points. Dust devils on Mars are much taller than they are on Earth, bigger, but they're not any more dangerous. In fact, they actually went over some of the rovers and cleaned the dust off of them without hurting them at all. So, some sand dunes on Mars. Which of these images of Earth do you think might be sand dunes? This one might be a little hard. You think it's A or B? 1, 2, 3, 4, 5. And
A.
the answer is indeed A. Here's some sand dunes in the Sahara Desert. You get those interesting forms from the wind, huh? Okay, here's an impact crater here on Earth. Which of these two is an impact crater on Mars, A or B? 1, 2, 3, 4, 5.
B.
And the answer is indeed B. A was a volcano. So sometimes kids might get these confused, and that's understandable. It's hard sometimes to tell. For the impact crater, the ground around it should be higher. For a volcano, the ground around it should be about the same level or lower. Okay. Amazon River Basin Network. Some images of Mars. Which one of these do you think is the right match for our image of Earth, A or B? 1, 2, 3, 4, 5.
A.
A is indeed right. A. So this feature looks a lot like Mars used to have rivers with water in them. And we're going to get to that in a minute. Which of these two images of Earth is an impact crater? Guess. 1, 2, 3, 4, 5. What are people answering?
B.
B is a popular answer, but the actual answer is A. B is the top of a crater, of a volcanic crater rather than an impact crater. So good guess. It's hard to tell sometimes, isn't it? It's hard to tell. Okay. We saw this picture earlier, right? It's got these dark features. That's actually lava. This is a volcano. So which of these features on Mars is the best match, A or B? 1, 2, 3, 4, 5. And the answer is
A.
A. Yeah. Okay. I'm going to just show you the remainder of the slides. There's a question here about which volcano, which of these is the tallest. Olympus Mons, this volcano on Mars, is much taller than Mount Everest or Mauna Kea. It's as big as the state of Arizona, or as all the Hawaiian island chains, or half the width of Texas. Here's some gullies in the wall of a crater on Mars, and we see gullies like that in picture B there here on Earth. We think they're from water, but the scientists aren't all in agreement here. There's still some disagreement as to what caused these on Mars. On Earth, they're caused by water, absolutely. Here's a picture of the Mariner Valley on Mars, and there's a question here about how long it is, and it's as wide as the US. And those are the questions that we've got. So you were asking about how to get a hold of this. I'm going to stop sharing it, and I'm going to show you the our workshop PowerPoint. So I wanted to let you all tell me what you think about the game. Is this a game that you would be able to use with your students?
I'm definitely going to use this. It's Laura. So I've been zooming into classrooms in New Jersey, and this is I can't wait to use it. So I've been doing it since April. And from my perspective and the students that are here, I think this is going to work very well. It's going to keep them engaged. And I think it's going to get them to work a little bit together. Because, I could say to them, why don't you two team up, and then, even put them in breakout rooms. I think this is fantastic. I'm
Thanks,
using it
Laura.
in February. I'm telling you right now.
Thank you, Laura. Does anyone else have any other thoughts on how you might use it or how you might change it or what you might do with it? And if anyone's raising their hands, if Sherelle, if you could let me know, I'll go ahead and we'll let them speak as well. People can enter things in the chat. You can see the link here to the actual activity, and the activity has the PowerPoint in it. The original version was played with cards instead. So
Christine, the other thing I really like about this, I'm sorry to come in again, is that it's also earth science.
mhm.
And so it's cross curriculum. And I know that around here, they want us always to sort of do both lately, like not so much when I was doing it in person, but in the virtual rooms, they want everything to sort of be together,
Right.
earth and planetary science. So I think I'm really excited about this, as you could tell.
Well, I'm glad to hear that. I'm glad to hear that. So in the last time that we gave this workshop, one of the teachers who was participating said that she would use this before doing the blue marble matches activity that Paige Graf has from Aries. So as a lead into this idea of comparative planet features, as well as getting used to satellite images. So.
Plus, I think it's a good way to gauge what they already know and some information that they might be lacking in. So I think it's really good all the way around.
I'm glad to hear that. I'm glad to hear that. I'm going to give everyone else just a couple minutes if anyone else has something they want to say or ask before we move along. And Sherelle, if you could let me know if anyone's entered anything in the chat.
Yes, so we have Linda that said that she wants to post this on her Discord group for her adult friends. They are science fiction lovers to play for game night.
Awesome. Awesome. That's wonderful. Thank you, Linda.
And Jim talked about doing online programs with Girl Scouts, and he'll definitely be using the Mars match for that as well.
Okay. Okay. Wonderful. Well, let's go on. Let's talk a little bit about Mars and Perseverance and why we're exploring it and all of this. So Mars has these features that we just saw. We saw Mars and Earth both have volcanoes. They both have craters. They both have canyons. They have similar features. And water once flowed on Mars. We saw some evidence of that, and I'll show you some of those pictures again. And so there's this question about life. Did Mars once support any sort of microbial life? Was there life on Mars? Maybe, is there still life on Mars? We have a lot of questions about Mars. And we think that Mars may have had this ocean at one point, a long, long time ago, early on in its history. There's this evidence that there was water flowing at one point. We have sand and features and types of rock that form in the presence of water, flowing water. And so this is an animation that is, has an artistic rendering based on Mars's current topography about what it might have looked like a few billion years ago, early on in the solar system, when it was warmer and it would have had a thicker atmosphere that would have held in the heat a little bit better than it does now. But what we do see now are these features. We see features of Mars, like the one on the right, that look a lot like a river delta when you compare it to the picture on the left of a color-coded satellite view of a river delta here on Earth. Or not just river deltas, but streams. Here we have a picture of Mars on the left and a picture of Earth on the right. These look like tributaries, right? And Curiosity has been finding things like rounded pebbles and sand that indicate that water was once flowing, and not only that there was water there, but we could also kind of estimate based on the types of sizes of the features how high the water was. And this wasn't water that just, appeared out of nowhere for a month and then went away. This water had to be flowing for a while in order to create sand and pebbles like this, in order to create what we're seeing. So this new mission, Perseverance, is going to be landing very, very soon, the Mars 2020 mission. It launched back on July 30th, and it's going to be landing on the 18th of February and going to be doing surface operations all this year. In a couple of months, the Ingenuity helicopter is going to take off and launch, and that's a technology demo. So for Ingenuity, we really just want to know, can it fly? Can we fly a helicopter on Mars? Can we make it work in the very, very thin atmosphere that we have on Mars? Mars's goals, it has numerous goals, including geology, understanding the rocks and the geology on Mars better, how they formed, how they changed over time. Astrobiology, understanding, were the conditions right there for life at some point? Is there any indication of any type of signature that might tell us that there might have been life? And then the Mars 2020 mission, Perseverance, is also going to go and find some of the really interesting specimens on Mars that we really want to study in detail on Earth, and it's going to collect them and create these little caches that we are going to go back later and retrieve with another mission in the future. So Perseverance isn't going to take off from Mars and come back to Earth. We'll need to send another mission to do that, to go and get these and bring them back to Earth. But it's going to collect them. It's going to go out there and collect samples. And then the more that we're understanding about the conditions on Mars, the atmosphere and the weather, the geology, what's going on there, the better we can prepare for when we do send people there. We want to make sure that it's going to be safe, that we understand all of the conditions that they're going to be dealing with and where the best spots are to send people. So these are all part of the goals for 2020. Where we will land. Here you can see a map of Mars showing where some of the past missions have landed, way back in the Viking missions when they landed in the 70s, to Pathfinder much later in the 90s, and Spirit and Opportunity, Phoenix mission that landed up near the pole, Curiosity and where it is now. And in this map, you can see areas that are very rugged with lots of craters and areas that are very smooth, either because they've been covered with lava or soil, silt filled in by an ocean that left deposits. And so if Mars once had an ocean on the northern hemisphere, you can kind of see boundaries as to where that ocean might have been up against the highlands that are so rugged with all the craters. Perseverance is going to be right on the edge there between some of the smoother areas and some of the rockier areas. And here it's going to land in Jezero Crater. These colors are false to help us understand more about the characteristics of it. But there were two channels that flooded this crater with water. And so this might be a place where there might have been microbial life. And so we're going to be looking for evidence of that in this area around the shoreline or the lake bed here. And scientists are going to use different instruments to search for these biosignatures. These can be any sort of object, substance, or pattern that life processes create. And So
We have a question, Christine, before we go there.
absolutely.
The question is, how far away will Perseverance land in comparison to Curiosity?
Oh, that's a great question. You know what? I don't know the exact answer, but I think there might be some people here with us who do. Jackie Allen, who has been studying and sharing and educating people about Mars for years, is with us. Jackie, do you know the answer to that one? And does anyone else know the answer to that one? How far apart are Perseverance and Curiosity?
I think we need to share her mic or video or both.
Let's.
Looks relatively close from your map graphic there.
It does, but Mars is pretty big. Mars is a third the width of the Earth. Let's go ahead and let me see. I was hoping that maybe somebody could enter something in the chat, but I will try to find out the answer. I'm not going to put anybody on the spot. We'll try to find out the answer, okay? Let's go ahead and let's continue. If anyone would like us to allow them to share their video or their microphone, say so in the chat and we'll promote you to panelist. Let's continue sharing. What we're going to do now is we're going to do an activity that I just love. And actually, I mentioned Jackie and I learned this activity from her. This is Searching for Life, or it's also called Looking for Life. And there's a few different versions of it. The version that we have on the LPI website is it's good for informal audiences. There's a classroom version that has that is far more rigorous, that would be good for in-class student activities. But for this activity, we're going to be looking for evidence of life. And I am going to stop sharing this camera and start sharing another one. Hold on. And let's go ahead and we've got a setup here. What we're going to do is we are going to pin and let's see here. Actually, not just pin, I'm going to spotlight for everyone. There we go. Okay, so hopefully everyone can see my three samples here, A, B, and C. And each of the samples has some sand in it and some other ingredients. That's C. This is B. And this is A. We're going to be looking for evidence of life in these three samples. And before we look for evidence of life, let's talk really briefly about what do we mean by evidence? What are the characteristics of life that we might be looking at, that we might be looking for? Does anyone want to say, what are some of the different characteristics? If you asked a group of kids what the characteristics of life are, what are they? What are we looking for here? Any ideas? Yes.
Able to reproduce.
Able to reproduce. So we might be looking for something to reproduce. Absolutely. What else?
Metabolize.
Metabolize. We've got organization. I see breathing and eating and reproduction and metabolism. Moving. Made of cells. And that goes with the organization aspect. Yeah. So we're looking for something. Homeostasis. Laura, can you tell us a tiny bit more about homeostasis for those of us who haven't taken biology in decades?
It just means that you're able to maintain your body temperature. So for us, it's an average of 98.6, but it goes from like 97 to 99. So if we get too hot, we sweat. If we get too cold, we shiver, and our body tries to bring us back to that central thermal balance.
Okay. Awesome. So we've got these different ideas. And what some of the smaller kids might say is, oh, well, it's everything that's alive moves, but you might think of some things that don't move very much. Plants move a little bit as they grow, but not a huge amount. And this idea of reproduction, yes, life reproduces, but so do viruses, including computer viruses, and that doesn't make them alive. So, so we have to have some boundaries, and it's really hard. It is hard to define life. But this idea that it does something, it breathes, it eats, it reproduces, and what some of it poops. All life poops. All life gives off, exhales something as well. So we're going to be looking for evidence that something is happening in these three samples. And all life needs nutrients. All life needs a fluid. Mostly water is the most common one here on Earth. And we expect it's the most common one in the universe, given the predominance of water. And it needs a source of energy, right? It needs resources, a source of energy. So for our three samples, we're going to start off by giving them a source of energy. We're going to give them each, I have some sugar here, and I'm going to give each of them a tablespoon of sugar. And I'm going to stir each of them. I've got a spoon. And like I said, they all need water. And I just happen to have a jug that I have heated up earlier of nice hot water that I'm going to cover them with. Ooh, do you see anything interesting? What are you observing? What observations can you make? Have you made? What are you seeing? Any thoughts, any questions, anything that you want me to observe for you? If I was doing this with a group of students, I might bring along scales and weigh the samples for them. I might ask the students to give me questions. So I'm going to ask you now, what questions do you have for me? Let me make the observations for you. So Stacy said responding to stimulus is a good thing for life. And John says that you saw gases being released. You probably saw gases being released. In particular, I saw a lot of bubbling from this one right here. I saw a lot of bubbling from this one. I'm going to stir it. And I see some more bubbles. That was A.
Christine, can you tilt the cups so we can see inside, raise it up?
Yeah, what we're going to do, we're just going to, yes, I can. Hold on though. Okay. So here.
Thank you.
Here we have A. A is now very cloudy, and the more I stir it, the more bubbles I see. Here's B. Not as cloudy. The water's a little bit clearer. It's somewhat cloudy the more I stir it. I don't see as many bubbles though. I see a couple, but not a lot. And the water was very warm, so the samples are all pretty warm. And here is C. And it's cloudier.
And we see most of your thumb and the spoon. If you can pull up a little, no, backwards towards you. There, that's a lot better.
Okay. So that's C. That's B. And that's A. Any observations or inferences so far about our samples? We will continue to observe them over a period of time, but any observations? This is C, B.
Yes, both Linda and Laura, they asked do they all smell the same?
Do they all smell the same? Mm-hmm. So A, smell, it's hard to define it. A smells, I want to say like salt. B, again, a little bit salty. It's hard to define those two. You know what? They smell like wet pavement. That's what they smell like. They smell like wet pavement. C smells like bread. C smells like bread that's baking. Any other questions or observations or inferences? A question about A, is the reaction in A sustained or is it subsiding? A, I don't see any more bubbles in A. Well, if I stir it, I see a couple more bubbles. So I'm stirring it and I see a few more bubbles, but then they go away. And B, I'm going to stir it and I saw one bubble as I stirred it. C, as I stir it, I see a few more bubbles. I see a lot more bubbles in C now than I do in either A or B. Thank you, Jackie. We appreciate it. So Jackie says that Jezero is about 400 kilometers from Gale. Awesome. Let's continue on and we'll come back to this. And please do not let me forget, we want to come back and take another look at this in a bit. So as if we're metabolizing the sugar. What is metabolizing the sugar? We'll find out, right? Does anyone have any other inferences so far before we continue, or questions? Let's.
Christine, I think there was a question about heating up.
Heating up.
Yes.
Okay, so the water that I put in was pretty warm. And right now, just based on my hands, it feels to me like A and B have cooled off, but C is actually a little bit warmer than A and B. So, and yeah, shining a black light on them. That would be a really cool thing to do. I like that idea, Linda. I don't have one handy. I do, but setting it up would be more trouble than it's worth right now. If we have time at the end, I'll try. That's a great idea. And then another thing that you could do in terms of the thermometers and the temperatures is set up an infrared camera to look at them and study the temperatures and where they're hottest. Let's, yeah, exactly, a thermal IR camera would be awesome. And adding some more questions there. C is definitely getting more cloudy and the foam is starting to get a little bit taller. I'm going to go ahead and try holding it up here, letting you see. So we'll come back and see what they all look like in a few minutes, but in the meanwhile, let's continue. I'm going to come back to the PowerPoint. We're going to go back to the PowerPoint now. And I will tell you the difference between the composition in just a bit. I promise, but I'm not ready to give it away yet. So we were talking about life and what life is. Life needs water or some sort of solvent to move around in, to transport its cells, if nothing else, and for reproduction. It needs an energy source, food or oxygen. It needs to be able to get that energy from its environment. It needs to grow or change or reproduce. It releases waste, it evolves, it adapts. All life does something and keeps doing it. And so while you're talking with the kids, with your audiences about what life does, you can you could set off your experiment, get it started, and then talk more about life and what it needs and what they're looking for, and then go back to it, because this is one activity that needs a little bit of time. The next activity we're going to do, and this one needs a little bit of time too, and it's a lot of fun, is making a paper helicopter. So you're going to, actually, Sherelle, I'm going to highlight your screen here for this one again. So let me find my pictures here, and I'm going to pin your video so that way everybody can see it. I'm going to spotlight you.
You want to give them a chance to.
Yes. Let's go ahead and let's have everybody get, everybody grab a piece of paper, and you'll need a piece of paper, pencil, and scissors for this one. piece of paper, pencil, and scissors. And so people are grabbing their paper, pencil, and scissors. What we're going to have you do for starters for this one is we are going to have you trace out one of these two paper helicopter outlines. You don't have to do both of them. You can do both of them if you'd like. So I've got it nice and big now. So if you're watching this from a screen, just put the piece of paper up on top of it and trace it. Or if it's too big or not quite the right size to do that, feel free to just do a hand drawing to get the basic idea here. What we want you to do is to trace and cut out one of these two paper helicopters. And hopefully people are back and they have their paper and their scissors and their pencils and they're starting to do it. So a paper helicopter here. Earlier we mentioned that Mars 2020 has Ingenuity, which is a helicopter that is going to try flying on Mars, which is remarkable. Mars's atmosphere is really, really thin, so thin that even during a dust storm, you're not going to get pushed over. The air just isn't thick enough. It doesn't have enough mass to create enough force to hurt you in bad ways. Unlike, that was one of the things in that movie where The Martian, where everything was destroyed by a storm. We don't think that would really happen. So this helicopter that they're going to be flying is going to have really, really nice big wings, and it's going to be very lightweight, and we'll see if we can make it work. What we're doing here for this activity is we're doing an engineering design activity. So the engineering design challenge, we're asking you to start with this format, with this paper helicopter, where you're going to trace and cut out, and we want you to cut along all of the dotted lines. Do not cut one of the straight lines that's filled in, but cut along the dotted lines where it's got A, B, X, Y, Z. Go ahead and cut all the dotted lines out. And then you're going to fold on the solid lines. And we're going to make a paper helicopter design that then we can test and improve upon. So for the engineering design, what you want to do is you want to come up with something that fits a challenge. And in this case, let's say our challenge is to create this paper helicopter that when you drop it, instead of falling at the same rate as a pen or a pencil, we want it to take a little bit longer. Let's say half of a second longer. And so you might test your paper helicopter by dropping it and your pencil at the same time and see that your paper helicopter takes longer. And then you might want to see if you can design one that takes even longer to hit the ground. And what could you do to make changes for that? So after you've got your outline, let me go back up first and stop sharing for just a second. Does everybody have their outline traced? Does anyone need more time to trace their outline? And there is a PDF available, absolutely, in the activity, and you are welcome to, of course. Not all students have printers, so they can't all print out it, but if you can, that's great. So Sherelle's got hers here. And Sherelle, can you go ahead and start cutting along the dotted lines for us and show us what that looks like? And you've got it after you've cut the dotted lines. So she's cut along the dotted lines, and then she's going to fold over A one way and B the other way to make like rabbit ears that are flip-floppy, like that. And then for the bottom part of it, the X and the Y, she's going to fold over the X and the Y. So that way it has a nice base. And then the very last part, the tip, she's going to fold under. The Z is going to fold up to kind of make that bottom part heavier so that her helicopter doesn't flip over while it's flying. How's everyone's helicopters coming? Does anyone have a helicopter ready? Yeah, Patrick does. Awesome. Linda, are you having trouble with yours? a little bit?
Could you show me that last fold of the bottom part again?
Yes.
I need to do A and B in opposite directions.
So A and B is rabbit ears. Actually, unfold the whole thing, Sherelle. So let's show it kind of flat out. Awesome, thank you. And so fold the X over like that, and then fold the Y over like that, and then fold the Z over like that. And now hold it up so that, yeah, that it's right side up, and with the top parts sticking out. Yeah. And now, yeah. Does that make sense? How's everybody else doing? Anybody else have a helicopter done? So for everyone who has their helicopters, go ahead and hold them up if we can see them. And the first thing I'd like you to do is just to see how it works. Jim says he's ready. Awesome. Go ahead and what I'd like you to do is just drop it and see what happens. Did it spin? What you should be seeing is it spinning. Patrick, thank you. That showed it quite nicely that it's spun as it fell. And if you dropped it and something solid like a pencil or a thumbtack or something at the same time, your helicopter should land a little bit later. It should take a little bit longer to hit the ground. It's that spinning, that action is causing it to slow down as it's falling. So the next step in this engineering design challenge is to decide how do we improve upon it? How do we make it better? How can you take this simple design, this helicopter, and you would challenge the kids. You could give them ideas, you could give them materials, you could give them suggestions, or you could have them work in teams. But how can they design one that works even better? So Sherelle here has one that's larger. I asked her to make one that was larger. Does it work better or worse, Sherelle?
It's definitely worse.
So it's an oversized one.
Yes, it's oversized, and the type of paper I use is almost similar to cardstock.
Uh-huh.
So it's just like really heavy.
It's really heavy, and so it didn't spin at all. It just kind of fell.
Right.
It flew like a brick.
Yes, exactly. Flew like a rock. Exactly. Just went to the bottom.
Okay. So does anyone have other ideas for what other modifications you might want to try to make to this that might make it better?
Laura mentioned to weigh it down with paper clips.
Yes, the original version that I'd seen had paper clips at the bottom to weigh it down a little bit to keep it more up and down. So absolutely, that one could work.
Actually, I think it works perfectly just the way it is. The little fold at the bottom, I tried it without that fold at first, and it doesn't work. So when you make the fold, it makes like a little pointed wing sort of thing at the bottom, which guides the body straight down.
Nice.
If you don't have the fold, it just kind of turns sideways.
Yep.
Linda mentioned for modification of materials to use a foam meat tray. And then C. Scott mentioned or tape pennies at the bottom to give it some weight. Dave said or a foam block to simulate instrument package.
Yep.
And then also Laura mentioned the kids might change the shape of the blades.
Absolutely. And Smitri, rubber bands to add some sort of a spin to it. And Jim said you folded the inside edge down a little and it spins faster. Nice. The formal write-up at JPL's website also suggests that as a way of measuring the effectiveness of it, that you could hang a ribbon from the bottom of it, and as it spins, as it's going down, the ribbon will help you determine how many times it spins, and it gives you a tool for sort of measuring how many spins you get in.
Christine, we also had on our Facebook Live page, we had someone suggest longer wings.
Longer wings, changing the length of the wings, playing with some of the different dimensions. Great point. And Susan said cutting down parts A and B in the middle for extra blades. So these are all great ideas, great modifications for this. So would you be able to do this with students virtually?
I think so.
Think so? Laura says yes.
I mean, we just did it virtually, so.
We just did it virtually.
Right.
And Kathy said changes the design is a great way to expand on the engineering design process. So it would take a little bit of practice, but that's what the engineering design process is about, is practice. And yes, Jim, it does depend on the age level. If you're working with very small children, they would need somebody there to help them with it. It's if you're working with, with 6-year-olds, 7-year-olds, 8-year-olds, they would likely need some assistance, in terms of the process. But when you get to older kids, absolutely. I am going to share. So this was the template, but it is available in a PDF, and you can share that PDF, the activity, with with your students as well. Let me go ahead and just ask them how to make it more efficient. Have a challenge. For any design challenge, your challenge needs to have a point. For me, it was see how slow you could make it in terms of falling down, but it could be see how many times you could get it to spin, for instance. So I've got some questions here for you to think about. And while you're thinking about these questions, I am also going to, I'm going to go back to our video of the life. Let's spotlight this one again. So earlier, here's A. It's still cloudy. I don't see any bubbles now. I'm going to stir it, and stirring it, I saw like 2 little bubbles at the side, but not much for A. For B, again, stirring it makes it cloudier, but I don't see any other changes. But for C, you might see some pretty big changes here. And I'm going to pick up this and let you see it from above. I'm having trouble getting it to actually look in exactly the right spot. Those aren't ice cubes. Those are bubbles. It might look like ice cubes, but they're bubbles.
It does.
Those are bubbles. So it's got lots and lots of bubbles here. So which of these might be showing evidence for life?
From Laura, she said C. Majority of everyone are putting C in the chat box.
Yeah, it did something and it kept doing it. It had evidence of that metabolism, of pooping, of exhaling, of creating bubbles. And the earlier questions, what was in, some of you already know the answer. This is a very popular activity. A had crushed Alka-Seltzer tablets. B, nothing, just water and sand. They all had sand. And C had the yeast. And yeast, make sure that when you add the water, that the water isn't too hot, that it kills the yeast, but make sure it's warm, that it activates the yeast. So C definitely has life in it, and that life is doing something. And if I let it stick around for another half an hour, it'll probably come up to the top of the cup. So what modifications might you have for our activities? How would you be able to use these? Do you have suggestions for everyone on what else you would like to do or you would recommend that they do?
Christine, I have one, of course. So I've been doing astrobiology workshops for many years, and I did, I don't know who came up with it, but I know it was NASA. Sam Coleman Kay and I were at an AppSciCon conference, and we did this activity, which I've done it so many times now, even if it's just for an icebreaker for teachers or something. And you put 3 cards on the top: alive, not sure. And I do this right before I do this activity, by the way. And then I put a whole bunch of stuff: virus, frog, cotton, marshmallows. You could really put anything in there. And then they put in teams, they work in teams, and they classify what they think is alive and what they think is not alive and what they're not sure of. And you put it all on the board, or you discuss it as a group. And using the standard 8 criteria for life that we were talking about, autonomous motion, homeostasis, cells, growth, reproduction, a mule is not considered alive because it doesn't reproduce. But a fire is considered more alive than the mule, right? And so it really starts to get a lot of their brains going. And then when they look at this activity, they really start thinking, well, wait a minute, is it growing? Is it reproducing? Is there a thermal reaction? And I've done this even at the World Science Festival outside, when Petri dishes and stuff, and people can hold it and feel that thermal reaction. So I can send you, it's really nothing to send. It's just the 3 cards in the top, and then you could fill it in with things that you think are, viruses, of course, are not alive. So people get very confused over that. And that opens up another discussion of what we think life is. So I don't know. I can't take credit for it because I know that we did it within that NASA, format, but I can certainly send something to you like what I do,
Awesome.
Yeah, and I think it's really helpful, especially as an icebreaker, and then a way to really get them thinking about what life is.
Yep. That sounds wonderful. That sounds like a great idea. Thank you. And Linda, I see you put some chunks of chalk in the cup that doesn't have anything in it, so that they saw something. Because the ones with each of the cups, if the kids are looking at them in person, they can see evidence of things, right? You can see the little itsy bitsy, even if you stir them in, they might still see some of the yeast. They might still see some of the Alka-Seltzer. So putting chalk in the 3rd cup as something different, that's a great idea, Linda. Give them something else to look for. I like that. I'm going to launch another poll. I see one of our participants had to leave because of audio issues. Hopefully he's back. So how much do you know about Mars? And I'm going to give everyone 5 more seconds to finish voting. 4, 3, 2, 1. And we've got a mixture in terms of knowledge about Mars. And of course, this workshop isn't intended to make you know everything about Mars. It was just to give you some ideas of things that you can do with audiences around this idea of perseverance in Mars. There's so much more to learn. And the more that I learn, the more that I discover I still have to learn. Does anyone have any other suggestions for modifications for any of the activities today that you would like to recommend?
The only other thing that I've done with the is it alive activity is if you have the ability to do it, because depending on your venue, is to hand out hand lenses prior. And let them look with the hand lens. This way they get that additional scientific instrument also, but then they really get to really dig in there and see what's going on. So that was the only other thing that I could suggest for that particular activity.
Great.
I also think we should try to tie it back to what the experiments are actually going to be on the Mars rover.
Yes.
When it's looking for life.
So you can tie it back to the different types of experiments and even the different instruments that Perseverance has. It's got a lot of different instruments on it. I didn't go into any of the ones that are around weather and atmospheric conditions, but it's got a number of those too. It's got a whole weather station on it. So absolutely. Thank you, Kathy. I'm glad you like the activities. Any other thoughts or feedback? Changing the glasses. The plastic could melt from hot water. These are plastic, and yes, using real glass would work nicely as well. Absolutely, because you don't want the plastic to melt. But you don't want frankly, you don't want the water hot enough to melt the plastic, because if you do have it that hot, it'll kill the yeast and you won't have anything. But yeah. You want them to be nice and clear. These fogged up from the warmth of the water, which made them harder to see virtually. So I don't know if there's a way to keep them from fogging up or not.
I've used Petri dishes. I've also used little containment jars, because, for instance, if you're doing a large venue like a festival, like the World Science Festival, I had to pre-do them, right? I couldn't sit there in between each person trying to make the mixtures, and plus they would see what I was putting in. So
Right.
you can actually use other things like little glass jars and cap them off. Like I said, I used Petri dishes, and you're able to cover them and put a little tape and then uncover them. So I don't think, as long as, like what Christine said, you keep it as clear, then it doesn't really matter what you're putting them in.
And Betsy, yes, if maybe for the scale paper strip, have the kids use one color on one side and a different color on the other side. So that way it's a little bit more obvious. And we might not have made it as obvious as we should have. The intent of the activity is, yes, to put your prediction on one side of the paper and put the actual answers on the other side of the paper. But using different colors will probably make it better. And I've seen some people let the kids actually draw or color the planets in there, which is nice, except it does take longer and you run into trouble when they're trying to put the actual locations for Mercury and Venus and Earth and Mars crammed into a couple of inches. But yes, different colors is good. Does this relate to some of the other things that you are already doing? Does this fit in with your curriculum, with your classes, with your informal education, with your programs, with what you're doing in a way that makes sense? Patrick is nodding yes. Are there other resources or ideas that would be valuable for you to have that you'd like us to know about? John asked if Martian life alive, is Martian life alive if it's dormant? There's so much we don't know, right? If a virus is dormant, it's still alive. But except viruses aren't considered alive. Viruses aren't considered life. But yeah, a bacteria that's just kind of sitting there, but that can still reproduce in the future would still be alive.
Well, plus you have things like my favorite little guys, tardigrades, water bears, that go into a ton state, and they could stay that way for thousands of years until conditions are suitable for them, and then they reanimate. I know Dr. Onstadt down in Princeton, he had a bacterium that was in a salt mine that was dormant for 10,000 years, and it was reanimated.
Yep.
That's insane to me. I'm sorry. When you start to think about things like that, it's just, I don't know, it really makes you wonder what could be alive out there.
It does. Lots of great ideas here. So using size and scale with virtual field trips, it should be nice. Yes, yeast definitely does go dormant. This idea of extending the pocket solar system, going out past Pluto, out to the nearest star, and giving them an idea that how far away the Voyagers are at that paper strip model, that it's 3 paper strips away. And so if the nearest star is 6 miles away, it depends on the actual size of your strip. But yeah. Activities about going back to the moon. We do have lots of activities, other resources. So I wanted to share with you, let's go back into slide sharing mode here so you can see some of these other resources. So here's some of the other things coming up around this idea of perseverance. And if any of you have questions about the virtual exploration experiences with planetary scientists, please type in your questions for Sherelle, because Sherelle leads those. And so we're doing one of those on Saturday, February 13th. Michelle and I can help answer your questions about the scientists and engineers leading the Perseverance mission, or the Making Our Way to Mars journey through space with NASA astronauts that will be working with the American Museum of Natural History and Open Space on that one. And then, of course, NASA has lots of ways that you and your audiences can tune in to watch the landing itself on the 18th. But in addition to these things, you were asking about activities around the moon. At LPI, we have a number of planetary science activities. Now, most of these were created for out of school time, for informal education, for camps, libraries, museums. Many of them can be done in the classroom, and many of them can be done virtually. So ideas around moon, we have 2 modules that are specific to moon, Marvel Moon and To the Moon. Both have activities, and some of those activities can be done virtually. And so email me for more information. I'll be happy to give you some suggestions. Tell me what age you're looking at and what amount of time, and whether you're talking about doing them virtually, and I'll be happy to give you some suggestions. But these are all on the LPI Explore page. In addition to that, JPL, of course, has a lot of activities around the Mission to Mars Student Challenge, and a lot of resources for educators, both formal and informal, around their Mission to Mars Student Challenge. The challenge started a week ago, maybe 10 days ago, and it's going to continue right up until the landing. And so they have resources that you might want to check out, lots and lots of them. And this PowerPoint, that's the wrong URL. We do want to thank Lockheed Martin and you and the STEMaction Center for making this possible, but I am going to change back to the very first page here, because this is the URL now that we have for the for this PowerPoint. And I have another poll question before anybody leaves. Please don't leave. I've got one more poll question before you go. That
Christine, John had a question. I'm sorry.
Absolutely.
In the chat box, he said, we're developing activities around Mars sample return mission. Any resources for that?
Around a sample return mission. Yes, there's a great there's multiple versions of an activity called rover races that can be modified around the idea of picking up and returning a sample. The original rover races activity was you blindfold the kid and they walk, and people send directions on how to get to where they want to go. But the modified versions don't require a blindfold. Some people thought that might be a safety issue. And so email me, I will try to send you our version, but JPL, there's like 2 or 3 different versions for rover races. And in some of them, the modification is when the rover gets to where it's going, it picks up the sample and then proceeds to not just pick it up, but move it to the correct spot. Now, the activity, in terms of the skills that you're developing around that activity, the skills are this idea of computing and direction, and communication, and how we communicate with the rover, rather than science of the rocks or something like that. And then there's a couple of others around the science of the rocks that might be of interest. There's a great one, Edible Rocks, that takes a look at how we analyze meteorites that could also be applied to rocks like rocks on Mars. So email me and I'll see if I can help you find some. And others, does anyone else have some suggestions? Because we've got a lot of great people here with us with a lot of knowledge. So does anyone have any other suggestions for resources for sample return activities for students?
One activity that I've done multiple times, and I don't know who to credit for this, because I feel like it's forestry, it's environmental, it's space, but you can put a pan out and put different materials in the pan. I'm sure some of you have seen this. I just don't know who to tell you to go to. But if you look online, you'll find activities that are already prepackaged for this. And inside, like fossils, maybe you could look for fossil exploration. And you put like pebbles or grains, and then you might put something that's like a cube, something that looks manufactured, or a bone, or something like that. And the kids get a tray and they dump out whatever's in their bag, and then they use a hand lens and they try to pick out things that might indicate that life existed somewhere. So it might be a mineral that's only developed in the presence of water, or in the presence of life, or it may be something, again, that looks like a cube that's manufactured, or maybe a piece of wood, right? So that would be considered life, right? So that's another cool activity that I've done that's really engaging.
Awesome. Great ideas. I have, and Jackie suggested, absolutely go outside and look at Mars tonight and invite all of your audiences to do the same. Mars is up in the sky right now. And that's a way to make it real, is going out, assuming that you don't have cloudy weather. I've got a final couple of poll questions here for you, and I'd love it if as many of you as possible could answer this. I will not be sharing your answers, so do not feel embarrassed. If you have a negative answer, I'm not going to say, oh, people shared negative answers. I would like as many of you as possible to go ahead and respond to the two questions. One, how confident are you that you will be able to use some or all of these activities with students? And number two, how useful was participating in this workshop to you as an educator? Linda, great idea. Small drones. Yes, yes. And in fact, there's, I can find some other resources on this idea as well of kites or drones that can include instruments on them that you can use to make observations. There's a group called the Aaron's Project that has drones and kites and kits that you can purchase for flying observations. I'm going to give 5 more seconds for ending the polls. 5, 4, 3, 2, 1. Thank you all so much. And the last chance to take a look at our samples here. Our yeast is started to subside now. It's no longer increasing. It is still noticeably warmer though than cups A and B. The sample C is warmer, that metabolism going on there. So I want to thank you all for joining us today. I really appreciate it. I appreciate your time. We know that right now you are struggling, everyone is struggling, but educators, formal and informal, and trying to reach out and serve audiences are under a lot of stress right now. And if there's things that we can do to help, please let us know. We appreciate your time and your dedication to what you do, and look forward to meeting with you again sometime soon.